Greetings, Coder. I hope things are well with you. Um, we're going to take a little look at number range because a lot of new stuff in there, and I think maybe we can learn something by having a little coding session. Short one. So iteration and looping are a big part of what we're doing in here. But even more so, or bigger, I should say, more important is calling methods on other objects. That's really what object-oriented is all about. Reusing, leveraging code, existing code. All right, so first thing I want to do is basically there's an example in this chapter. We have the challenge, and we almost always, or probably always, have an example that is very close to the gets us going on the challenge anyway. So I downloaded the example, which is available for download, um, and I have that right here too to reference. All right. So then to get started. Basically, what we do have here is it gives us a couple of instance variables for the number range. It gives us a constructor, and it actually gives us the code for this other constructor. So there's nothing new there really. Here's the instance variables, and there's the constructors and some accessors. Now let's get to the new stuff, the interesting stuff. Let's see what we have here. Instance methods. Okay, so where can we start? We can start, I would say, with even count is kind of really going to be we're going to develop a pattern in here that we can follow for most of the rest of the other problems. So even count, obviously there's not a parameter, it doesn't describe any parameter, and so there's no method parameter. It returns a count. So we know it returns a count. Okay, so let's remember that. And actually, remember this for testing. Run tests, and it gives you a test that you can run. So again, returns the count. Okay, so the method is called even count. All right, so public, and it returns a count, which is going to be an integer. We know that. No parameters, so like that. And the first thing I'm going to do is I'm going to return the count, even though here it's going to be obviously always 0, but it gives us that hint. Let's go with it. Let's run with it. Again, returns the count. So all right. So now we just have to do the actual work. So I'm going to go to the example here and look through the methods, and I find that there's a count here in this example for the chapter. I'm going to copy that in because I think we can probably use the same kind of logic here. I'm actually going to just copy this. I'm not proud. I'm going to copy that in here and see if that pattern will work for us here too. So our method is not get left like the example. It's get start, I think. Yes, get start. And we also have a method called get stop, I think. Get stop. All right. So that iterates through the list, all the numbers. And that's our iteration variable. We construct a smart number, then given that number, that loop variable n. And if we want, we could actually rename that to a loop variable. I don't know, which is clearer, but that's a loop variable. It goes from start to stop. It's going to have all the values. So if our range is 1 to 10, that loop variable is going to take on all the values 1 through 10 for each loop. First loop is 1, second loop is 2, third loop is 3. All right, so smart number. We have here a new smart number, and we want to count the evens basically, right? So do we have a method that will work for us? We do. We have a method on the smart number called isEven. So if it's even, we're going to increase the count and return the count. So you notice how that example, the pattern in that example worked for us right here. And that's the method. And we have a variable here. So, or I should say we have an error here. Get start, get stop, loop variable plus plus. Type mismatch long. Oh, that should be a long. We're using longs in this challenge, aren't we? We are using longs. Okay. So that has to be a long as well. Okay. There we go. No errors. All right. Let's see what we can maybe do here. Let's do odd count here. which is another method that we're going to do, odd count. Very similar, except we're counting odd numbers. We could kind of copy this pattern, but we can make this even easier. Let's odd count. Basically, it's just our range, the size of our range minus the even count, right? All the ones that are not even have to be odd. They're either even or odd, right? So we're going to return this size minus this even count, that method that we just coded. So in other words, if we have 10 numbers in our range and 5 are even, or 6 are even, let's say 10 minus 6, 4. So actually it would be more like probably 10 minus 5, 5 and 5. So we don't have the method size. That's fine. Let's add that method then. That's a little helper method. Let's add it. Helper method, or it's just an other method is all it is. Okay, public long size, and that size is going to be return this stop minus this start minus 1. So remember, the start is actually included in the size, so we want to subtract that 1. So, all right. And we can kind of prove that by if our range actually is from 10 to 10, we might expect the size to be 0 there, but it's actually 1, because I mean there is 1 in a range, right? It's the 10th, it's the number 10. So let's do a check here. Check this stop minus this start is also 10 minus 1, and that equals 10 minus 9 equals 1, and that's what we expect. The number 10, one element. All right. So that's how we can do that one. Let's count primes now. Let's do a method called that we're coming up to here, called count primes. Return the count of prime numbers in our range. All right. That's going to be similar to this guy here, I think. So count primes. 168 in 1 to 1,000, I think. All right, so similar thing. We're just looping from to our range. We're getting constructing a smart number. We're not interested in if it's even or not. We're interested in if it is prime. Increase the count and then return the count. And I made a little typo there. Is prime. All right, so that's how that works. What else can we look at here? And we would do a summation. There's also, I think, a summation of primes. That, of course, is very similar. The only difference there is this is a sum. And sum equals 0, so instead of plus plus sum, or we would want sum equals sum plus the loop variable, the number there. So, or if you want it to be more efficient, sum plus equals. These two lines are equal, lines 74 and 75. This is just an abbreviated version of this. All right, so now we have some primes. Okay, let's take a look at another method here. It's a little bit different, just to get a little diversity of problem here. Let's take a look at the shrink method. So no return value. It receives a parameter, which is a factor used to shrink. And we round when we take our length and we factor it and we round. Okay, let's take a look at what that might be involved with. No return value. All right, so in that case here, we would write the method like public, no return value it said, so void shrink. It says there's a factor that comes in as the parameter. And we no return value. Okay, so we're going to use the smart number even in this case here. we'll use a smart number because a smart number has something that's useful, and that is it has, we want to round, divide our number, which is the size object here. All right, let's see here, smart number, size. We're going to take our size, actually. Our size. So in other words, if we're in the range of 1 to 10, our size would be 10. So now we have a smart number that's wrapping that or modeling that. Now we want to get a new length here. New length. And that's going to be equal to the size object divide, we'll use that divide and round method we did in there with the factor. So in other words, again, if we're 10, if our number is 10, we're going to divide and round by that factor, which might be 3. So we would expect a new length to be 3 then, rounded, right? So we would then just simply set the length to the new length. And we're done with our shrink. We don't have a method called set length. That is not a problem. It's just another helper method. So these can be private or public helper methods. If we're just going to use them ourselves, we can set them as private. Either way, doesn't really matter too much typically, unless we're dealing with passwords or something, and then they definitely should be private. All right, set length. So the long new length, and we simply then do something like set our stop value to a new value based on this start as the basis plus the new length. And again, the first one counts, so we subtract 1, and there we go. All right, well, I won't go too long here, but that's a few methods here. And the thing is, as you can see, the big thing is just to leverage what we've already done. In each method here, we're using that smart number to get a result that makes life easy. This is a pretty lightweight class compared to smart number, right? It's not, each of these methods is a few lines long, following kind of a similar pattern. All right, so we'll talk to you soon. Thank you.